Hello, everyone. Thank you very much for joining us for today's webinar on working with point clouds in TBC. I will wait for maybe 10-15 more seconds to make sure everyone is attended, and then we'll start presenting. Okay, so today my name is Babak. I'm here today with Marvin Midahi. We both work out of Calgary office, and I'm going to be the main presenter today, and Marvin will help me out later on the question and answers at the end of this presentation. Today's agenda, we are going to talk about what is a point cloud and what formats will be accepted in TBC software, what are the applications that point clouds can be used for, and I will speak about the TBC tools for working with point clouds. And at the end of the presentation, we will have some question and answers. Hopefully we have enough time to answer some of your questions. As always, this webinar will be recorded and will be sent to all the attendees of this webinar. And make sure whenever you have a question, write that question on the question panel, and then we'll make sure to answer that at the end of the presentation. Or if we don't have time, we will definitely get back to you with some answers. So I wanted to start with a very basic explanation of what a point cloud is. You know, a cloud is a 3D mass made up of small droplets, crystals, water, or various chemicals. In the same way, a point cloud is a huge number of tiny data points that exist in 3 dimensions. And the reason that the idea of point cloud has started to be used is we can manage a huge amount of data in our computers. If we treat all those point data with an actual survey points, it's not manageable. So each one of those points are presenting X, Y, Z coordinates in a 3-dimensional space. And at the bottom, you can see a very nice looking point cloud and how that's the idea of this mass data capture mean and what we can get out of a point cloud data collection. So okay, we have point clouds when we're always talking about the point clouds, and we have a lot of data, we have a lot of information from the point clouds, but now what we can do with the point clouds? Generally speaking, the point clouds are close to unrefined oil. And in order to manipulate this data, we require to have some software to work with this data. And there are a lot of software out there to work with the data, like RealWorks, Scene, Revit, Recap, Cyclone, Rescan Pro, Point Tools, Topodat, and VRMesh, and so many more applications that I'm pretty sure a lot of people are familiar with or they have heard of. But today's focus is on Trimble Business Center, which is a complete survey and construction office software. And that's the general message from Trimble, which enables field to finish workflows with confidence. And why is it important? What is different in Trimble Business Center compared to other software is the survey engine. The engine of Trimble Business Center has been a very robust and slick survey engine that has been around for a long time. And what Trimble has done is bringing scanning capabilities through the scanning module to the survey engine. And that is a distinguishable point and critical point of, or maybe I can say that it's advantage of Trimble Business Center compared to a lot of other softwares, that's very rich and comprehensive survey engine that will provide us with the opportunity to create survey deliverables, survey quality deliverables. And in terms of the formats that are accepted by Trimble Business Center, these are at the top, you can see all the available formats. Some of them are industry standards like E57 and LAS, some of them are ASCII format, some of them are from different competitions. These are usually called the point cloud with unknown origin. At the same time, especially with the release of Trimble SX10, which was a total station with scanning capability, there are point clouds that are accompanied by a job file or JXL file, which carries the information about the coordinate system and about the survey practice that was done in the field. So depending on what type of point cloud that we want to import into Trimble Business Center, there are considerations that must be taken into account, and these are very critical. As an example, when we import a LAS file into Trimble Business Center, right away we see a message saying that what type of point cloud you're trying to import. Is it the ground scale package? Is it georeference grid scale point cloud? Is it coming from an unknown or generic format? And these are the considerations that every user of point clouds, when they want to try to bring them into Trimble Business Center software or any other software package, they must pay attention, because especially working with TBC, because it has a survey engine, when we bring the point cloud and we start a TBC project as an example with a template, we need to know what type of coordinate system we're dealing with. If we don't do that, the point cloud might scale in a way that we cannot understand why is that happening, and that consideration is very important. And everybody here, you can join us at Cancel, and we have a lot of experience with that to help you to understand how the point cloud should be imported. There are some rules of thumb that I wanted to put it here. In order to make sure an efficient import of the point cloud, always start your project with a template. Like back then when CAD World started implementing templates to drive or to standardize CAD production deliverables, the same concept exists in Survey World. When we start our TBC project or any survey project with a template, we make sure we have the standards in place before importing any data into our projects. Always, it's a good idea to check against existing control. If you have used some control point to georeference your point cloud, definitely make sure you check your point cloud after importing against those control points. And the third option is extremely critical, is always check against known distances. I'm pretty sure a lot of you people have heard about the grid and ground coordinate scale factor, and that scale factor can be a combined scale factor, can be a projection scale factor, because right now we all work with a predefined worldwide geodetic coordinate system. And the same concept exists. Whenever you want to work with the point cloud and you bring them into a survey engine, that scaling can cause some issues. Make sure you always check your point cloud data against a known distance to basically bring you confidence, to be confident that your point cloud has been imported and ready for manipulation or deliverable production. So there are different applications for point clouds. There is a very limited list, and this list is can be expanded to a lot of different applications. Some of them are topographic general survey applications, roadway and corridor surveys, volumetric surveys, infrastructure as-built, building as-built, tank calibration inspection, mine surveys, dimension controls, and so on. Here I want to just summarize some of the applications. What are the benefits of using point clouds for these applications? One of them is a topographic general survey application. You basically can capture more site detail and context in less time. You can safely capture intersection detail without traffic control, and you can avoid site revisit for missed details. And I really want to emphasize on this point here, which is one of the most important factors that must be taken into account if any organization is deciding to use point cloud for deliverable production, as an example for topographic survey, because site revisit is always a very expensive task in organizations. Another example is a roadway corridor survey. The benefits can be measuring safely without costly traffic management, and actually enhance site visualization for design and collaboration. And going on with the volumetric surveys, which has become very popular in terms of using point cloud technology, and that point cloud can be from actual laser scanners, can be from UAV, but that is a very good tool for volumetric surveys. Basically, productivity through innovation, combining accurate survey control and dense scans to capture complete surface areas can be considered a benefit. Definitely increase safety by avoiding walking on piles or around heavy machinery. And we all know how surveyors are happier when they don't have to walk all those piles. And I've done a lot of projects in the landfills, and I know how it feels. And also enhance visual context to understand site conditions and communicate to stakeholders are also other can be considered as a benefit of using point clouds. So we can talk about infrastructure as-builts. Basically, rapid capture of rich asset information is very important. Reduce station setup and ability to capture data on inaccessible objects, example, long bridge spans, because if you want to do that traditionally, we all know that we have to do a lot of reflectless shots to measure all those points. But with the point cloud, when the data is captured, all of the information can be extracted from the point cloud back in the office, which basically very important. And also complete geometrical information and visual documentation to enhance communication. Usually when we have point cloud information and we provide stakeholders with the visual information of the site, it is very convincing and very important for the stakeholders. And there are many more applications like building as-builts, building and facade elevations, mine surveys, power line inspections and clearances, and the application can be limitless as long as we know the tools and we have the tool to manipulate the point cloud data. The applications can be limitless on this part. So talking about those applications, as we mentioned at the beginning as well, we're required to have some tools, or required to have a survey, a software to be able to manipulate that data. And these are the tools that I want today to focus on about TBC and what are those tools providing us. I have divided them in two parts because we believe that a lot of our customers are just focusing on the first four tools to be able to create a clean data set and export that to the third-party software for further deliver production or anything that they want to do in third party. But again, there are other customers that they want to use featured session tools and also finally produce some deliverables out of TBC. We'll focus on all of these, and I have some nice demonstrations for you that I'm going to show you in the next slides. First of all, when the data comes in, usually the first task of working with point clouds is registration. In other words, we have to stitch the scans together. Unless the data is coming from hardware like SX10, and the person who has done the survey has followed the survey practice, so the data comes in as registered already. But in a lot of cases, we need to bring the scans and register them together. And here you can see where the registration command is accessible under point clouds. And there are two different types of, or two different methodologies that exist right now. They're available for us for registration. One of them is called plane-based, and the other one is pairwise. The plane-based is for the data that comes from Ferris scanners or Trimble scanners, and it's a plane-based registration. And the pairwise can be done on any sort of point cloud, which is the cloud-to-cloud registration. The next two slides and next two demonstrations, I'll show you how to use the plane-based registration command and how to use the pairwise registration. Here I have started a TBC project, and all I need to do to do a pairwise registration or plane-based registration, I'm sorry, I need to drag and drop my scan file. This one is a TZF format coming from Trimble scanner, and like all other data importing to TBC, you just drag and drop them in. And once the import is done, you can see all these point clouds are all piled up on each other because they're not registered yet. They're relatively not stitched together. And we would like to basically use this plane-based registration. And again, we can use the plane-based because this data is coming from Trimble scanner, or it can be from Faro scanner. So I do have tools under rendering tools to look at my data by true color. In this case, I wanted to look at them by scan color so I can distinguish between different scans coming from different station setups. And after that, under the point cloud, I need to click on the register scan, and it will direct me to the registration command, which I can automatically go ahead and register my scans. So the workflow in general is you bring in your scan data. First, you need to stitch those scans together, and you probably sometimes you don't care about the georeferencing one because you just want to have a relatively correct or stitched whole point cloud together, and that's what it does in this command. I pick one of the stations, reference station. It doesn't matter which one you pick, and you register the remaining scans against that one. And I will pick my reference station at the top, and I have my moving station at the bottom of that pane. And all I need to do is to click on automatically register, and it will try to do the registration based on the plane-based algorithm that is in place inside TBC. And just to tell you the truth, this engine is coming from Trimble RealWorks. Trimble RealWorks is dedicated software from Trimble for working with point clouds, and these algorithms are imported or implemented inside TBC Scanning Module from Trimble RealWorks. So after that automatic registration is done, TBC will provide us with the opportunity to create a report out of that registration, which is extremely important in terms of having a QC/QA tool or report out of that registration, which will provide us with some measures on the quality of the registration, which brings us confidence at the end of the day about the quality of the product that we want to create out of that point cloud. As you can see, this is very simple and very intuitive. You just need to pick the reference station and the moving station, click on automatic, and it will try to do the registration. Again, there are techniques, there are ways that sometimes it just doesn't work, like we all know. We need to basically work with the reference station, moving station, change them to finally find a way to register these scans together. The next option or the next method for point cloud registration is called pairwise registration. In this example, this is the data coming from SX10. You can see these data at the right-hand side are captured in the field as free scans, which means that those are not captured with a survey practice. What I mean by survey practice is having your station setups, your backsighting, regular total station survey practice, I mean, or you did not any resection, you just set your total station or SX10 and a scan. By keeping that in mind that you have to have some common features or common areas compared to your actual georeference scan so you can stitch them back together later in the office. And that's what we're doing here. I'm going under to the registration command, and I'll try to register these using pairwise method, which is a cloud-to-cloud registration. In this pane, again, it's very intuitive. In the left-hand side, right here, this pane shows my reference stations, which are all georeferenced and are done with survey practice. They're georeferenced based on the existing control they had inside. In the right-hand side, here is my moving stations. And at the bottom, you can see them relative to each other with two different distinguishable colors. So after registration, you can do quality check on those visually. And here is where you pick your moving stations and reference stations. In this case, I'm picking all the reference station, all the station which are georeferenced as my reference. I'll pick the moving stations and I hit automatically register pair, and it does the magic for me. Here I'm moving my moving stations, and after that I'll pick on the automatically register pair. I'm trying to fast forward this video, but apparently I'm not successful. Something happened in my, excuse me. I don't know what happened. Nothing is working on my computer now. Marvin, do you see my screen now? Marvin?
Yes, I'm seeing your screen. Yep, I'm seeing your screen. Quite fine. You're on page 21.
Yeah, but the problem is right now, see, I cannot go back to.
Which page would you like to go to?
No, I mean, something is stuck in my Zoom It application that I'm using. See, it's zooming and zooming out. Excuse me, people, I'll try to
just
fix
close
this.
the program. Yeah, just close the program and restart it if that's simple enough for you.
Yeah, probably I will do that.
Yep, just restart it. There we go. Save.
Okay. Sorry, everyone. We're going back to normal. Okay, yeah. So going back to here, I picked my reference stations, my moving stations, and I'll hit on automatically register pair. And you can see at the bottom, let's start registration, and it will give me some statistics on how my registration was performed. But again, general rule of thumb here is do not trust those numbers that you can see at the bottom. You always need to visually check and QA your registration at the bottom. Again, the red one is there's reference stations, the green one is the moving stations. Here at the bottom, I can see how they're stitching together very nicely. And then after that, I can add to the reference and move to the next stations. But a very important technique here is because sometimes the data is a way that it cannot find a good matching between these reference station moving stations, TBC will provide us with the opportunity to align or to pick two common points manually ourselves if it doesn't work. And because this methodology is based on least squares, what it does, it uses those common points that you pick from here, as in from the moving station and from the reference station, use them as constraint and help the least squared methodology, which is an iterative methodology, to stitch them together more efficiently. I've been very successful, and based on our experience, majority of the time, most of the time, as soon as you pick this automatic registration, it does the job. In a lot of cases, again, not a lot of cases, but it happened that it could not find, I will go ahead and find two common points, and it will help the registration. So now, let's assume that you brought in your scanning data, and then you try to stitch them together. You ended up with a relatively correct or stitched together point cloud like you see in this video. But at the end, you would like to bring them to an actual real world coordinates or any coordinate of the project site, any coordinate system, coordinate frame of the project site. And that is where you use the georeferencing command inside TBC. In this specific example, I have started my TBC project with a predefined coordinate system. I have brought in 4 control points that are used, or they're actual controls that I'm going to use for georeferencing. And I've got all the nodes from the field from the field. I know which point is related to what point on the scan. I will use the georeference command at the right-hand side to pick my point from the point cloud, and also pick the relevant point from the point list that I brought in already to my TBC project. So now I'm picking the point from the point cloud. I will direct that to the point from the actual survey point that I'm going to use. And what it does, it's a very simple coordinate transformation. So if you have more points, you will have redundant information. It will run a least square adjustment. It will provide you with residuals of your points, and then it will apply the transformation. We receive this question a lot from our customers. If you have a point cloud, how we can move that point cloud? Georeferencing command is a way that you can move your point cloud from any existing frame to another frame based on some control point that you have. That's the only way that you can move your point cloud around this georeferencing command. At the right hand side, I can see I've picked my point number 1, my point number 2, and I'm going to move ahead and pick my other 4 number. I have 4 points here for georeferencing. I can look at the residuals on these, and then once I'm happy with the residuals, I can basically go and fine tune the point cloud selection if I want to, if the residuals are not good. And after that, I'll hit on georeference, and my stations, my scans will move to the georeference locations, and I can visually check the quality at the end too. And I have these numbers as a QCQA tool that I can document for later. So we have registered the point clouds. We have georeferenced them. And another very important tool that is provided to us to make working with such a huge amount of data easier is the classification. And that classification is, again, a very automatic command and doesn't require a lot of knowledge. You basically, when you bring your data, they usually go under the point cloud regions as a default regions, one region. Like we have the concept of layers in CAD world, we have the concept of regions inside TBC for point clouds. They're all classified as one region. When we click on the sample classified point cloud regions, it will provide us with the opportunity to classify our point cloud into 4 different regions: ground, building, poles and signs, and high vegetation. And I pick that, I click on extract, and Trimble Business Center will try to classify those for me and colorize them differently so I can distinguish between those regions in my data. So right now you can see at the bottom that is doing the extraction. I'll fast forward this so you can see the final result. Okay, right here, I can see Trimble Business Center could create 27 buildings, a lot of maybe 30 something poles and signs from my point clouds, and each one of them are selectable separately and can be seen. The ground is brown, high vegetation, all the trees are green. And this is an option that I decided to have. I wanted to have buildings separately. In the next, I can show you how I can merge them together. For example, if I want to have all my buildings as one building region, I'll select them all together and I right click and I say, okay, I want to merge these regions together into one building region. And the reason for that is sometimes you will see the next slide is I want to export just my buildings or just my high vegetation to a third party. I can merge them all together, come up with one unique building region and select that and export that for down the road to work with that point cloud and third-party software. That's what I'm doing here. I can do the same thing for the poles and signs, select them all together, merge them into one region. I can see at the left-hand side, they're all getting merged together. It's and ended up with one building region at the end. The same thing applies to other regions that I want to do. And like any type of classification, any tool from any software, they're still not 100% correct, and it will never be 100% correct because that is an algorithm. Depending on the complexity of the data that we have, there are some errors. As an example here, you can see one part of that tree has been classified as a building. You can see that from the color. Cleaning part is one of the tasks of the people who work with the point cloud in the office. So right now, I'm showing you one example of how we can clean up that data and adding that wrongly classified tree to the tree region. So what I will do, I'll go to my 3D view, or I can use limit box tools. In this case, I'm just using the 3D view because it's very easy to look at this data from 3D view. I have my selection in polygon mode. I go around that part of the tree, I select that, and then right after that, there's a command in TBC called add to region, and I will add it to the tree region. And this is one task, one of the things that we should do always before starting extracting features from the point cloud or sending this data to the third party for further drafting purposes or any sort of deliverable that we're looking after. And the reason that we are doing a lot of these inside TBC, or we suggest to do a lot of it inside TBC, because it has a very good intuitive and stable tools to work with these type of information and have those data ready for the next steps. So now you can see I could easily select that part of the point cloud and clean that. So we have done with the classification too. Finally, for a lot of people, we just want to export them to a third party, and how we can export those point clouds, and how sometimes we are having a very dense point cloud. As an example, if you want to create contours from your ground, you definitely don't need every 1 centimeter point cloud. You just need to sample that point cloud first, right? The first option that I'm going to show you here is having my ground region on, and I want to use a sample point cloud region and how we can downsample the data. When I click on that sample region, it will provide me with two options. Those two options are sampling spatially by a specific type of distance that I want having my sampling, or I can sample that randomly. There are pros and cons to each one of them. Depending on the application, you should make an informed decision on which method you want to use for sampling. In this specific example, I'm using the spatial sampling, and I use 1 meter spacing for my sampling. And I have already selected the ground region. I'll hit store. What it does, you can see here, it goes through the sampling. It will provide me with another point cloud region, which is 1 meter. And this is definitely good for original ground surface creation, making the assumption that you already have all your line work from curb and gutter and all those information, put them all together to create your original ground surface. And then I can select that region and go ahead and export that, in this case, into any format that you want. That will have a slide for you that shows all the available format for exporting. In this example, I'm exporting that in LAS format. I can go ahead and do the same thing for my high vegetation, select the high vegetation, click on it, and export that to another LAS, and all those information can be sent to third-party software for downstream manipulation and delivery production. That's what I'm doing here. I'm exporting the buildings from this. And again, in terms of exporting, we have a lot of stakeholders that they do not understand the point clouds. They do not want to deal with the point clouds. And all they need from a survey or from a service provider is a CSV. CSV has been around for a long time, and still a lot of people just want to see the point in CSV. We have a command in TBC that is designed to provide us with this functionality, and that is called scan to CAD. I can select one region of my point cloud and create some CAD points, which downstream can be converted to survey points. And during this process, I can sample them too. In this example, I'm trying to create samples with the spacing of 2 meters, create CAD points from my ground region. So as soon as I hit that, some CAD points will be created, which after that, I'll use another command, which is converting those CAD points to survey points, which will provide survey quality points out of point cloud for me. And that is where I can use them to visualize in Google Map as an example, or I can export with a specific order with a specific pointing numbers and with specific feature code. Here I can pick, I want to basically create some survey quality points. Starting point is, let's say, 20,000, and I want to put them on layer. I did not put any feature code, but this example I could put as an example if I have my feature code library in place, OG, and then that data will be exported as north and easting elevation. And you can see here that this data, which is created from those CAD, are survey points, because you can see grid coordinates, local coordinates, and global coordinates, which means that this data can be exported to Google Map for visualization, or can be exported easily with those point numbers to a CSV and sent to our stakeholders. Okay, these are four different types of tools that are available for a lot of our users, and majority of users are using them. And these are the formats that you can export your point clouds. Some of them are industry standard, some of them are for specific brand. Let's say Recap, which is very popular, is for automatic recap. We have the ASCII format, PTS, PTX, Bentley point tool, POD, LAZ, LAS, E57, and TDX is data exchange format between TBC and RealWorks. These are available format that you can export your point cloud, or at the end of the day, if you don't want to export the point cloud that I showed you, you can use the available commands inside TBC to create survey points and send them to your stakeholders. Okay, so these are done, but still TBC is very active in providing the end user with some automation or automatic tools for extraction. And this extraction is extremely important. As an example, for the topographic plan creation, TBC provided us a very nice tool for extracting trees. So these trees can be extracted automatically, and here I'm showing you an example of that. After the classification is done, I will have my high vegetation region on, and there's a command I can go under point clouds, and it says extract point features. You can, one is on, I will stop here for 1 second. See at the top, you can see we have the option to automatically extract features, and we have the option to manually extract features. In this case, I'm going with the automatic option and see what it does. As soon as I select that, I can select my starting point ID. In this case, I will start with 2000. I will pick a feature code that have already been imported into my TBC project, because I already started my TBC project with a template which contained a feature code library. And I know what that feature code library is. I know what that specific feature contains as an attribute, and I can use those attributes that you can see at the bottom to map the information that Trimble Business Center can extract from this point cloud. Once it does this automatic feature extraction, it can extract the tree spread, trunk diameter, and tree height, and I have used them as an attribute in my feature code library to be able to map them or connect them together. It's a mapping exercise. And after I click on that extract features, it will go ahead and try to find these trees from the point cloud. This part of TBC is coming from a software from Trimble called Trimble eCognition. And this automatic feature is coming from that engine. As you see, TBC's message is to be a central hub for surveying construction professionals. And they are adding nice tools and commands from different software tools that they have. They try to integrate those with the survey engine of TBC, which is a very hard task. But so far, they have been very successful in these integrations. So it brings in, it tries to find all those trees, and I can fast forward this a little bit, although it's very fast. There you go. So I have all my trees selected. I can visually go ahead. There are tools I can visually check, quality check them to see which one is correct, which one is not correct, if I want to ignore some, if I want to exclude some of them from the list. And then at the bottom, at the left-hand side, I can, because my feature code library is smart and comprehensive, I have included those as an attribute, I can map them to the actual information that will be extracted from these. And as soon as I hit add, it tells me 122 points were created from these point clouds. And if I select any of those points now, I can see they have the survey information, which means northern eastern elevation, lat and long, and also they have the attributes mapped to them. Look at here, I have the trunk, I have the spread at the height. These information can be exported to a CSV, can be integrated and into a Esri geodatabase from our GIS module, can be exported to a Google Map, depending on what you want to do with this data down the stream. There are tools inside TBC that can help you in this task. And last but not least, we just try to show you some of the tools that are available. It's not all of them. The last one is the line extraction. Very important task that everybody's asking, and I can tell you this: what I'm doing here in this case is for curb and gutter extraction. So I have my TBC project started with a specific template. I have my standard feature code library in place, and I would like to extract this curb and gutter information from this data. I know what the feature code is for the top of curb, and I have a tool called Point Cloud Smart Pick. As soon as I click on that, it gives me a more zoom view of that curb and gutter, which I can fine tune and find the actual point on that, the top of the curb. And then I will use my line control codes. I'm pretty sure a lot of you are familiar with the line control code. This is the concept of surveying in the office. I'll pick my point from the point cloud. I'll introduce with the actual survey code, and also I'll introduce with some line control codes to be able to extract top of the curb, flow line, edge of pavement, back of the curb, depending on the structure of that curb and gutter. And I will go ahead and like click, click, click on top of the curb, and it will finally, you can see, after processing my feature code, which means that I will want my TBC project to create those line works based on those survey code that I'm using. The line work will be created. Now I pick for every single new point, it will show me, because I'm on a smart picking tool, it will show me a zoom view of that curb and gutter. I can fine tune, make sure I'm picking the right spot. Look. And then after that, when I process my data, which I move forward because you have seen this. And here you go. So we can extract some line work. We have heard from Trimble that they are actively working, and they have announced that recently in their latest webinar. They're actively working on bringing us some tools for line work extraction, automatic line work extraction. This is something in their development, and they are saying that they did not give us any specific timeline, but it will be available for us very soon within TBC, which will be a game changer in terms of extracting line features from point cloud. Because the point features has been around, and then it's very good. It's getting better and better. But line work is always hard to implement as an algorithm, but it's coming, and we are hoping to see something like that very soon inside TBC. I think that was all we had today for you. We hope that we could show you some of the availability, some of the functions that are available to be able to efficiently work with point cloud inside TBC. And at the end of the day, you can create a different deliverable from your point cloud. This is an example of power line clearances that is extracted and created out of TBC, and we can create reports for that. You can create survey plans using the available drafting tools and CAD standard that you can bring inside your TBC project. You can basically create 3D views of your surfaces in a mind survey and provide that for your customers. You can basically work on creating surface from the point cloud and provide the customer with the cut and fill report or volumetric report. These are all the deliverables that you can generate from your TBC using the point cloud data, depending on the application and depending on the requirements of the organization that you work with and software infrastructure, you will make those decisions on what software and how they should be used for producing deliverables. I think that is what we had to you for today. I think right now we have some time. It's almost 11:45, but we can still stay for 3-4 more minutes and answer some of the questions that you might have. Again, if you're not able to answer your questions now, we will definitely get back to you later with some answers. Thank you, everyone. Marvin, I will leave it up to you to pick some questions if there are any questions, and we can answer them.
Sure, no problem, Babak. So again, the floor is open, guys. Please feel free to start typing in all the questions that you might have, and we'll try our very best to answer them as best as we can. All right. So we got one question here. I noticed that you had an example of a tunnel view. How can I see inside a certain full dome scan? Okay, do you want to answer that?
Yeah, go ahead. All right.
So we have several different options inside of TBC for visualization, as was shown in the example. We do have a very good three-dimensional view that allows us to pan around in a space, but as you asked, when you're inside of a full dome, it does present a challenge. So there is the option for what is called a limit box that allows us to slice into a certain object, whether it's from above, below, or side, and we can orient that box depending on how we want to. But we also have a command that is called see inside. And what that does is it just basically, based on the perspective view that you're using, it trims off the immediate point cloud. And if there is a gap between that section and the back wall, for example, like a cube, it will basically make the front amount of points become transparent so you can see inside of the building. And then we also have another feature which is called the cutting plane view. And that's where you can define an actual plane and state the thickness that you want to see. And that will be presented in like a 2D view where you're able to see inside of the structure. So we have many different options, and these are all covered whenever we try to go through a training scenario with our clients. All right, good question. Here's another one. How can I merge existing surface information with my SX10 scan? All right, good question. That is very much something that a lot of our clients do. They do drones, many different kind of photogrammetry activities, and so they have their LAS files or they have their surfaces. As Babak had shown in the illustration, there is the scan registration tool, right? That is one option for pairing point cloud to point cloud. So we could pair the actual LAS from the data. So instead of trying to pair the scan, we would pair instead the LAS that was used to make that. But we also remember that Babak highlighted that there is the georeferencing as well as an option. So that is an option that we can also use as well to be able to move them so that they're correlated to the same common point. So the key there is between both of them, we need to be conscious of the coordinate system being used and also the actual correlated georeference points that are being used to tie them together. So the software can either do a scan registration, or we can actually have the software doing a georeferencing, or we can manually translate the information as long as we have common tie information. Good question. All right, we have one more. How can I share this information with a client or a stakeholder? Good question. There is an actual web application that is created by Trimble, and that is Trimble Clarity. And that is where you can actually publish your scan data directly to the cloud. and have a client look directly at that link. So they're able to do the same kind of general visualizations that are done in TBC, where you're able to see it in real world, if it is that it has the proper coordinate system, and be able to orbit around in that space and have a look at that. And you can even apply, for example, certain CAD functionality, such as measuring distances, checking areas, trying a cutting plane, turning off and on layers, stuff like that. So that is available, and basically you can load those based on project requirements. Good question.
I would like to add something to this one. In
Sure.
case any of our customers have their own sharing tools or software systems for sharing the point cloud, that still can be used, because you can export these point clouds after manipulation, after whatever you want to do with those point clouds from TBC in an acceptable format by that software package, and then use that sharing tools for your customers. Which means that you don't have to always use Trimble Clarity, although it's provided us with a very interoperable and seamless system to share with your customers, but that's not the only option.
Good, definitely. All right, let me read off this.
I think.
Okay, we're up at time.
Yeah.
All right.
Okay, thank you everyone for joining us. We hope that we could provide you with a good webinar and a summary of tools that are available for you for working with point clouds. Definitely feel free to reach out to us at Cancel, that we can help you in any of the questions that you might have. Just to bring to our attention, we have started to offer some online courses, which are usually 4 hours courses, and there are courses related to working with point cloud and TBC as well. If you're interested, I encourage you to check our website for the list of the courses and the dates, and register if you are interested. Thank you very much again for your time today. Thank you, Marvin, for helping me today on this webinar, and we'll look forward to working with all of you more closely in the future. Thank you.